So session 4 deals with quadrilaterals and circles. Now there are tons of rules. So the purpose of this video is strictly for you to get the rules into your notebook so that you have them to look up when we're practicing. Quadrilaterals are four-sided figures. The most general quadrilateral is a parallelogram. And notice that it doesn't have as many check marks as the other one. Please take a moment to copy down all of the properties of all four of the main quadrilaterals that we work with. Notice that when it's checked off, it means that that quadrilateral has those properties. So a parallelogram, opposite sides are congruent and parallel. Opposite angles are congruent. Diagonals bisect each other, and consecutive angles are supplementary. Remember, that means 180. A rhombus gets a little bit more in detail. All sides are congruent. Again, opposite sides are congruent. Same with rectangle and square, etc., etc. Please take a moment to take all of these and make this chart in your vocab notebook. Pause the video if you need to. We created this hierarchy chart already. As a matter of fact, it's what's on the wall in the classroom as well. A quadrilateral is a general four-sided figure. Please remember, if something has only two parallel sides, one pair of parallel sides, then it's a trapezoid. A regular trapezoid doesn't have to have consistent sides or congruent sides, whereas an isosceles trapezoid has a parallel side pair and then a congruent side pair. The four quadrilaterals that we focus on are the parallelogram, which is the general most quadrilateral in this particular category. A rhombus is a parallelogram. A rectangle is a parallelogram. And a square is a rhombus and a rectangle and a parallelogram. So a square has all the properties of the three main, the three hierarchy quadrilaterals that are above them. And then a kite is kind of in its own world. A kite has no parallel sides. The diagonals are perpendicular and the markings are on the kite. Please take a moment to draw this picture as well. Circles have tons of rules, as we have learned. The pieces to a circle, the main pieces, are the diameter, the radius, the chord, the secant, and the tangent. Please take a moment to draw each of these and write down each of these rules as well. An inscribed angle is an angle that touches, the vertex touches the outside. The inside angle is half the arc. So for example, if this angle is 30, then arc AC is 60. Maybe you want to write that down. A central angle is an angle that the vertex touches the center. The central angle and the arc are equal. This is actually a typo. The central angle equals the arc. Cross out that 1/2 right there. Oh, there's another typo. Central. Sorry about that. So take a second here. A central angle, if this is 60, then arc CA is also 60. Please take a moment to write these two rules down. We talked about exterior segments. Exterior segments are created in this particular case with two secants, but sometimes you have a secant and a tangent. This is the wee property. You have the whole times the exterior. So A plus B is the whole. The exterior is just the outside part. This is the wee. Whole times exterior. Please make sure you're writing down these rules. Interior segments, notice all of the segments are inside. This is PP. CD, if you multiply C times D, it equals A times B. Please write down those rules. We also talked about interior and exterior angles. Exterior angles means that it's an outside angle. You take the major arc, which happens to be right here, A, B, C, and you subtract the minor arc right here, which is CDA, and you take half of it, which is how you get the 1/2 major minus minor. That's the exterior angle. Interior angles, again, the inside of the circle, but not touching the center and not touching the outside. That's an interior angle. This would be the major arc plus the minor arc divided by 2, and there's the formula for that. And then the last two that are probably the most popular questions, if you have a quadrilateral inscribed in a circle, we learned this to be a cyclic quadrilateral. We don't see that very often, but we did learn it this year. And that's when opposite angles add to 180. So A plus C equals 180 and B plus D equals 180. And then finally, when you have a bow tie picture or a shared arc, angle A is created by the arc DC. Angle B is also created by the arc DC. They happen to be inscribed angles, so the two angles are equal. If angle A is 30, arc DC is 60. Well, if arc DC is 60, angle B is also 30. So if two angles like A and B share an arc, then those angles are also equal. Have a great day.